Welcome back, guys, and in this tutorial we're going to continue with our study of tangents and circles. Now, in our first tutorial on tangents and circles, remember, a tangent is a line that intersects a circle at one point and is perpendicular to the radius. Okay, so a tangent is a line, okay, a fancy word for a line that intersects a circle at one point and is perpendicular to the radius. Okay, both of these properties are going to be very important as we go through the next three examples. So in example 3 here, which you'll find in your notes booklet, it says find the equations of the two lines parallel to the line 3x plus 4y minus 6 equals 0, and which are tangents to the circle x squared plus y squared equals 25. A sketch of the line and the circles are shown, which we can see here on the right. The two tangents parallel to 3x plus 4y minus 6 are shown in red. Well, now this is an important rule that we remember from our study of coordinate geometry of the line, that any parallel line is going to have the same value in front of the x and the y, and it's the constant that will be different. So any parallel line to 3x plus 4y minus 6 equals 0 would be 3x plus 4y plus k is equal to 0, where we don't know this constant k. And we know that's true because the slope would have to be the same. Now, bearing that in mind, let's look at the circle. So we can see that our formula given for the circle is x squared plus y squared is equal to 25. Which we can see resembles the formula we did at the very start of coordinate geometry of the circle, which is x squared plus y squared is equal to r squared. So if that's the case, therefore we can say that the center of this circle is 0, 0, and we can say that the r squared, the radius squared, is equal to 25. So we're going to square root both sides to find our radius, so I can see that now that r, my radius of the circle, is equal to 5 units. So now adding that into the diagram, we can see that the center 0, 0 and the radius, which is 5 units, would be the length of the perpendicular line to both of our parallel lines. Which means if we're looking at the perpendicular distance, this is where we're going to use our formula from the top of page 19 in our log tables, that our perpendicular distance is equal to the modulus of ax1 plus by1 plus c all over the square root of a squared plus b squared. Now we know that our perpendicular distance is going to be equal to 5 because that's our radius. And we know our a, b and c are going to be taken from our equation of any parallel line. So now we're going to fill in our formula here, and let's try and work through this together. We have 5 is equal to, our x1, y1 are going to be at the center of our circle, 0, 0. So we're going to have 3 by 0 plus 4 by 0 plus k all over the square root of 3 squared plus 4 squared. And remember, we're trying to find the value of k. So we have 5 is equal to the modulus of, and it's important to remember that 3 by 0 would give me 0 and 4 by 0 would give me 0 because anything multiplied by 0 gives me 0. So we have the modulus of k is equal to the square root of 9 plus 16, over the square root of 9 plus 16. So we have the modulus of k is equal to the square root of 25, which means we have 5 is equal to the modulus of k over 5. So now I'm going to multiply both sides by 5 to get the modulus of k by itself. So we're going to times both sides here by 5, which means I get the modulus of k is equal to 25. Now this is where we need to remember important properties about the modulus. The modulus in there means that our number could be a plus or it could be a minus. Because remember at the start of this question, it says they want to find the equation of the two parallel lines. So if the modulus of k is equal to 25, That means, therefore, k could be equal to 25, or k could be equal to negative 25. It could be either, okay? Which means now we're going to have our equation of the two parallel lines, where we're going to sub back into our equation of the general parallel line, which was 3x plus 4y plus k. So we have 3x plus 4y plus 25 is equal to 0 is our first parallel line. And we have 3x plus 4y minus 25 equals 0 is the equation of our second parallel line. So I want everyone to take a minute here to go back through example 1. We're going to add it into our note, or example 3. We're going to add it into our notes booklet, and then we're going to move on to example 4. Alrighty guys, so looking now at example 4. It says find the equations. Again, that's very important, it's plural. The equations of the tangents to the circle x squared plus y squared is equal to 5 from the point 0, 5. Well, if we look at our equation of a circle that we're given here first, we have x squared plus y squared is equal to 5, which again resembles the very first equation we learned in coordinate geometry of a circle, which is that x squared plus y squared is equal to r squared, which means that we know this is the equation of the circle when the centre is 0, 0, and we also know that means r squared would be equal to 5. So again here I'm going to square root both sides, so now I can see that r is equal to the square root of 5. Now, bearing that in mind, I'm going to draw a rough diagram here to help me visualize my approach to this problem. I can see that I'm going to have a circle with the center 0, 0 and the radius of the square root of 5, which would look something like this. They've told me that the tangent is going to go through the point 5, 0, which we know is on our x-axis. So I'm going to put that point over here as 5, 0, which means we could have two different tangents here. We could have a tangent with a positive slope where it's increasing, and we could have a tangent with a negative slope where it's decreasing. So we could have two tangents that look like this. Bearing in mind again that the distance from the center to the tangent would have to be square root of 5 because that's our radius. Now, a tangent, remember, is a fancy word for a line. So if we want to find the equation of any general line, we're going to use our formula. Y minus y1 is equal to m by x minus x1. We know both tangents contain the point 5, 0, so I'm going to sub in 5 and 0 as my x1, y1 into my general formula. And what I don't know, and what's going to distinguish the two lines, is m. So when I sub them in here, I get y is equal to mx minus 5m. I'm going to rearrange this by bringing it over, so I get minus mx plus y plus 5m is equal to 0. And now I know that the perpendicular distance between these two lines and the centre of the circle is going to be the same as the radius, which is the square root of 5. So again here I'm going to use my perpendicular distance formula to help solve for m. All over the square root of a squared plus b squared. So a lot of this is coming back to the perpendicular distance formula. My perpendicular distance is going to be equal to the square root of 5. My x1, y1 is going to be the centre point 0, 0. A is going to be minus m, b is going to be 1, and c is going to be 5n. So let's sub that in now and see what it looks like. So we get the square root of 5 is equal to the modulus of minus m by 0 plus 1 by 0 plus 5m all over the square root of minus m to be squared plus 1 to be squared. Okay? Which means now we have a bit of algebra to be working out here. So first of all, these two are going to give me 0 because anything by 0 just gives me itself. So I get the square root of 5 is equal to the modulus of 5m all over the square root of m squared plus 1. Okay? So now what I'd see here is that I have the modulus of the square root of m squared plus 1 on the bottom. I'd rather not have that on the bottom, so I'm going to multiply both sides by the modulus of the square root of m squared plus 1 and multiply by the modulus of the square root of m squared plus 1, which is going to cancel then on the right hand side to leave me with the modulus of 5m is equal to root 5 by root m squared plus 1. Now, this is where we need to remember the modulus to form two different equations here. So I'm going to say that in the first one, 5m, which is my modulus, is equal to negative root 5 root m squared plus 1, because it's going to be negative. The second time I'm going to say that 5m is equal to the positive root 5 squared by m squared by the root of m squared plus 1. Simpler actually. Rather than doing it this way, we can go back to the opposite of assuming that to make it positive we can square both sides, which will make my maths here a little bit easier. So I'm going to square both sides here, and when I square both sides, that means I get 5 by m squared plus 1 is equal to 5m squared is 25m to be squared, which means I get 5m squared plus 5 is equal to 25m squared. I'm going to bring everything to one side, so I get 0 is equal to 25m squared minus 5m squared minus 5, which means I get 0 is equal to 20m squared minus 5. Now I can see everything can be divided by 5, which would give me 4m squared minus 1, which means now I can use the difference of two squares, which means I'm going to have 2m and 2m and 1 and minus 1, because we're using the difference of two squares to factorize here. So just to bring you back there, guys, here we divided by 4 to simplify. Here we're using the difference of two squares to factorize, and now I can let each bracket equal to 0 to solve for m. So I have 2m minus 1 is equal to 0, so 2m is equal to 1, so m is equal to a half. Here I have 2m plus 1 is equal to 0, so I have 2m is equal to minus 1, so m is equal to minus a half. So now what I'm going to see, guys, is I'm going to end up with two equations where m is equal to a half and m is equal to minus a half. So I'm going to bring that back over here to sub it back into my general equation for the tangent. So the first time I'm going to let m equal to plus a half, which means I'd have minus by a half x plus y plus 5 by a half is equal to 0. So I get minus a half x plus y plus 5 over 2 is equal to 0. To get rid of the fractions, I'm going to multiply everything by 2, which means now I'm going to have minus 1x, minus 1x plus 2y plus 5 is equal to 0 as the equation of my first tangent. Then I'm going to take it that m is equal to minus a half. And again I'm going to substitute it into my general equation for the tangent. So now I have minus by minus a half x plus y plus 5 by minus a half is equal to 0. So that gives me positive a half x plus y minus 5 over 2 is equal to 0. Again, I'm going to multiply everything by 2 here to get rid of my fractions, which means I'm going to get 1x plus 2y minus 5 is equal to 0. And so finally, at the end of that sum, my two equations of the tangents are minus 1x plus 2y plus 5 is equal to 0, and 1x plus 2y minus 5 is equal to 0. So I want you to pause the video here, guys, go back through, watch example 4 again. We're going to add it into our notes copies or our notes booklet, and then we're going to look at the last example today, which is example 5. Which you'll be glad to hear is a little bit shorter. So in example 5 here, it says find the length of the tangent from the point minus 5x to the circle x squared plus y squared minus 4x minus 6y plus 3 is equal to 0. So the first thing I would do here is write my general formula for a circle underneath. X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And from that I need to find the centre and the radius of the circle. So I can say therefore 2gx is equal to minus 4x, 2fy is equal to minus 6y, and c is equal to 3. Which means I'm going to divide everything, my x's cancel on both sides and I'm going to divide both sides by 2. My y's cancel on both sides and I'm going to divide both sides by 2. So I get g is equal to minus 2. And I get f is equal to minus 3 and c is equal to 3. Which means by page 19 in my log tables, my centre is minus g and minus f. Which means I'm going to have 2 and 3 as my centre because a minus by a minus is a plus and a minus by a minus is a plus. Then my radius is equal to the square root of g squared plus f squared minus c. So I get the square root of minus 2 squared plus minus 3 squared minus 3. So I get the square root of 4 plus 9 minus 3, which gives me the square root of 10 units as the radius to my circle. Now, it says find the length of the tangent from the point minus 5, 8 to the circle. So from here I can draw a rough sketch, guys, to see what my circle is going to look like and what this tangent is going to look like. I can see that I have an x and a y axis, that my centre of my circle is 2, 3, so it's in my positive coordinates here. I'm going to draw the centre of a circle, or the sketchings of a circle. They're saying that minus 5, 8, which I know would be back across the x-axis somewhere here, is on a tangent to the circle. So not on the circle, it's on a tangent to a circle. Okay, which would look like this. So I have minus 5, 8. I don't know the point of intersection. I know that this centre is 2, 3. And if I connect these three, I can see it starts to form a right angle triangle. I know that this guy is the radius, so it's going to be the square root of 10. I don't know the distance here, which is, I'm going to label x, which is what they want me to find, is the length of the tangent from the point minus 5, 8 to the circle. But I can find the distance between minus 5, 8 and 2, 3 using my straightforward distance formula. So I'm going to label this x1, y1 and x2, y2. And I'm going to use that my distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Which means when I sub these in, I'm going to get 2 minus 5 to be squared plus 3 minus 8 to be squared, which gives me 7 to be squared plus minus 5 to be squared. So I get the square root of 49 plus 25, which gives me the square root of 74 as my distance here. So now I'm going to label this the square root of 74. And I can see in a right angle triangle, when I have two sides and I'm missing one side, we're going to use Pythagoras' theorem, guys, right back to the junior cert, to find the missing side. The side opposite the right angle is going to be my hypotenuse C. So now I'm going to write out my formula for Pythagoras' theorem. C squared is equal to A squared plus B squared. So I have the square root of 74 to be squared is equal to the square root of 10 to be squared plus x to be squared. So I get 74 is equal to 10 plus x squared. I'm going to bring my 10 over to the other side and he becomes a minus. So we have 74 minus 10 gives me 64 is equal to x squared. To find x now, I'm going to square root both sides. So I get x is equal to 8 units. So the distance from that point to the circle on the tangent is going to be 8 units as my final answer. Now guys, take a minute here, pause the video, go back through example 5. We're going to add it into our notes booklet, and then we're going to try a few questions. This was a long tutorial today, guys, but make sure to be adding these into our notes copies and make sure that we fully understand before we try to solve any questions. Alrighty guys, thanks very much and well done. Keep up the good work.